Hey guys, Mr. Mackey here. Now, yesterday I introduced you to a sample space diagram, which is one of the many methods we could use to lay out and display probability. And I set you this challenge, where I rolled this dice twice. And when I did, I multiplied the two results I got. So let's just do another recap. I rolled the dice once and I get a 4, then I roll it again and I get another 4. So I multiply them two together, so the answer I got was 16. And I wanted you to find the probability that I got a 12 as my overall product, or that my product was bigger than 30. And this is what our sample space diagram is going to show us. So let me just fill this in and then we'll get cracking on. So, there are 36 different outcomes that you can get from this because there are 36 products on this diagram. So, what I'm going to do is I'm going to circle with my blue pen the numbers 12 whenever they appear. So there's one there, there's one there, there's one there, and there's one there. Have I missed any? No. So, the answer we'd write for the probability of there being a 12 is for every, out of 36 outcomes, 4 of them would be a 12, because that's how I'd win if I get a 12. But I could simplify that to 1 over 9. Now, I'm going to use my red pen to find the numbers that are bigger than 30. There's only one, 36. So the probability is out of 36 events, only one of them I'll win. So the probability is 1 over 36. Now today we're going to be using the probabilities that we have found, thanks to sample spacing, and what we did in Monday's video, and we're going to make predictions about other events occurring. Let's see what we mean. So, I have a coin, a 10p coin, and I'm going to toss this coin 10 times. Out of those 10 times, how many times will I get a heads when I toss it? So before I toss it, I need to predict how many times I will get heads. So, what we need to do first is we need to find out what the probability is that I would get heads. So, we need to consider that. Now, the answer to this is because there's two outcomes, heads or tails, and only one of them is heads, the probability is 1 over 2. Now this probability, this likelihood that I would get a heads occurs if you toss the coin once. I got a heads that time. But if I toss it 10 times, what you have to do is you have to multiply that probability by 10. And when you do, you will end up with 5. And that is my prediction. If I was to toss this coin 10 times, I am predicted to get 5 heads. Another clue for how we know that is 1 over 2 is the same as a half. 5 is half of 10. So let's see. I'm going to toss this coin 10 times. So I got a heads the first time. Heads twice. Heads 3 times. Heads 4 times. Heads 5. 6. I got tails the 7th. 8, tails twice, and tails 3 times. So when I toss this coin, I actually got heads 7 times and tails 3 times. Now even though this is quite a difference between 5 and 7, 10 is still quite a small number. If I was to toss this coin 1,000 times, we might get a more accurate representation of a half. If I was to toss a coin 1,000 times, that would mean that I would probably get 500 heads. What this is basically telling us is sometimes predictions can't be trusted, because I predicted that I would get 5 heads simply because the probability is a half, but I didn't. So what you should do is you continue tossing and tossing and tossing this coin, and then eventually you will reach 500 heads out of 1,000, which then makes the probability more reliable. But overall, that's enough about the lecture. I'm sure you're probably sick and tired of this. You want to see me do more stuff with coins. But let's move away from coins. Now let's try something else. Instead, I'm going to focus on two coins, 10p and 20p. And I'm going to toss both of these coins at the same time. And I'm going to do this 100 times. When I do this, how many of those two simultaneous tossing of the coins will both the results be heads? So if I toss them, what is that? How was my prediction of how many heads will I get when they both get tossed? So, firstly, let's find our probability. Probability that you get heads times 2. Now this is going to be different because the probability of you getting a heads in one coin is a half. But remember when we did our sample space diagram with 2 coins, that comes a little bit different because there's 4 different outcomes. Because you could get heads both times, you could get tails both times, you could get heads the first time and tails the second time, or you get tails the first time and heads the second time. There's 4 different outcomes. How many of those outcomes means I win? Well, only one of them. So the probability that you get heads on both of those throws is 1/4. But I was going to toss these coins 100 times. So you multiply that result by 100. Which means that if I was to toss these coins 100 times, I would get 25 heads appearing both times. Now, because I'm sure you don't want to see me do this 100 times, I'm going to stop the video now, I'm going to do it, I'm going to write the results on the board. See you in a minute. Well, that's some minutes of my life I won't be getting back, but it was worth it to show you that when I did it, I actually got 23 heads out of that 100, which is very close to my overall prediction. So you see, the more times you do it, the better your prediction and more reliable your prediction will be. Now let's move away from coins and let's look at something different. So, I have a dice. Now, I'm going to roll this dice 60 times. 60. How many times when I roll this dice will I roll a 4? Any ideas? Well, the probability that you get a 4 is 1 in 6 because this dice has 6 different outcomes. So what you've got to do is you multiply that result by 60, so you are predicted to get 10 4s when you roll it. Let's see. I'm having a clearly very unproductive day. I rolled my dice 60 times, and these are the results. I got 11 1s, 12 2s, 9 3s, 13 4s, 7 5s and 6 8s. So not only did my 4 appear 13 times, which was the most out of any other number, it was fairly close to 10, even after 60 rolls. So as I said, even though it may not be bang on the same, it's still quite close out there. If it was, for example, after 6 rolls, I didn't get any 4s, I might have raised my eyebrow a little bit going, that's a bit strange. But it is fairly close. Let's try something a bit different. What if I rolled this dice 1,000 times? How many times will I get that 3? Well, the probability that you get a 3 is 1/6. What you do is you need to multiply that number by 1,000 and you will get 1,000/6, also known as 500/3. Anyone know what that is as a simplified version? That's the same as 166.7. So obviously you can't get a 0.7 of a roll. You can't. So what I do in these is I round it up to the nearest whole number. You don't round it down because it makes the prediction less in your favour. So I round it upwards. So I'm predicted in this case then to get 168 threes in this roll. You might be about 1 or 2 off, but this is the closest and most accurate prediction you can get. So let's look at it like this. You're at a fair, and you see this stand which charges 50p to take part. The person who runs that stand asks you to choose a number on a dice, so any number between 1 and 6. He then rolls this dice 10 times. Okay? If you get 3 of that number, you get your money back. If you get 4 times that number, you win £1. But if you get anywhere less than 3, you don't get your money back. So if I chose, for example, the number 1, if I got a 1 3 times, I win my 50p back. If I rolled the 1 4 times or more, you win £1. If I got a 1 2 times or less, I lose my money. Should I do this? Now, the best way to think about this is, how likely is it that I would get my money back? Now, this is your challenge for today. I want you to come up with a sensible argument to convince me whether it's a good idea that I should do this. If I roll my dice, will I be guaranteed to win some money or get my money back? Find a suitable argument, prove your case, and we'll see what the results are tomorrow. Good luck. It's a bit of an interesting question, because you're going to be thinking a bit outside the box for this time. But good luck with this. Take care, and I'll see you tomorrow for some more probability.